Okay, so let's get started. So we are in section 8.4. So last time we started, we were talking about um, the hypothesis testing for the population proportionality. So we use the test statistics as a z. So z is given by p hat minus little p over square root little b times q over n. Remember that p hat is coming from our sample. So p hat is given by x over n. So x is the number of years. So we are looking for the success, number of successes, which is x, right, among all n samples. So then we use this and we use the z distribution, and the remaining are like as usual. So we had three assumptions. So these are, the common thing, right? When you use the testing, we use these two. But the last one is, the condition should satisfy. If you multiply the sample size with the probability of success should be bigger than or equals to 5 for n times q as well. After that, we did this problem last time, right? We finished, I believe we finished last time this one.
Yes, sir. We walked through it. Yes, sir.
Yeah. So now let's look at example 2. The report stated that 21% of babies are delivered by a cesarean section. The researcher believes that the percentage is less than 21. Okay, so whenever we see the percentage of something, we know that that is going to be proportion, right? So this is he is suspecting whether the little p, the population proportion is what is that? Researcher believes that is less than 21. So that's going to be our alternate hypothesis. As null hypothesis is going to be 0.21, right? So 21% is going to be 0.21. So basically this is a researcher's claim, right? So now the remaining all like same. So alpha is 0.01, and the random sample is 15. So therefore p hat is formula says that x over n, then x over n. What is that? So he is targeting, how many, the patients got a baby by C-section. So there are 8 of them. Oh, sorry. So it is 8 of them out of 50. Therefore, P hat is 8 over 50. That is 0.16. So little p is our hypothesis says that which is a 21%, that is 0.21. Therefore, little q is going to be 1 minus p, right? So that's going to be 1 minus um, minus 0.21, right? So it's going to be 0.79. Okay, so I believe this is not correct, right? This is not correct.
Yeah, because your P was 0.21.
Yeah, so this is not correct. No, I'm talking about the Q. The Q should be 0.79. Look at here. Here they are putting correctly, right? 0.79 for Q. But here they say Q is going to be 0.84. That is not correct. Q is 0.79, right? So let us subtract 0.21, not 0.16. Okay. Therefore, the statistic is going to be p hat minus p over. So if you're plugging all the values, p hat is my sample proportion, which is 0.16 here, and the little p is my problem hypothesis 0.21, and over put p times q is 0.79, not 0.84. Okay, so you have to change there. This is not correct. Okay, so this is our test statistic. Keep that. So now remember, my test is now left tail test. That is why you have left tail. So this is a critical value. So where's my alpha then? My alpha is 0.01. So this is 0.01. Then find the critical value. So how do you find this value? This is my z value. So the critical value is given by what? Inverse norm function of this left area, right? 0.01. So if you find this one, that should be negative 2.23. Okay, I have the critical value, but my test value say that is negative 0.868. That is far away from your critical region. So this is my test value. This is my critical region. Therefore, obviously, my test statistics is now falling inside the non-critical region. Therefore, we cannot reject the null hypothesis. Therefore, do not reject the null hypothesis. Okay. So to summarize, there is not enough evidence to support your claim, right? There's no evidence to support your alternate hypothesis because we did not reject it not. Okay. So this all I explained last time. So use the one prob z test to use the calculator. So you will get the same answer. Okay. Do you have any question before going to next chapter, next section? Okay, then let's move to 8.5. This is about, again, testing hypothesis, but for the variance. Okay, right. So now what is test statistic? Here we use, since this is a variance problem, we use chi-squared as a test statistic, chi-squared. So the test statistic is here n minus 1 times little s squared over sigma squared. So little s is here the sample variance, sample standard deviation, and squared is sample variance. Okay, so now we are going to use the different table here because this is a chi-squared problem. So again here we have the assumption for chi-square test value. The sample must be randomly selected and the population must be normal distributed. Okay, this is the key point, right? Your population should be normal distributed and the observation must be independent of another. Okay, all the observations should be independent. So now look at this problem. A psychologist wishes to see if the variance in IQ of 10 occur counseling patients is less than the variance. So he is checking whether they're less than the variance. Therefore, it's going to be less than my alternate, right? The population is standard deviation or variance is given 225. So that is going to be my population variance. Therefore, my null hypothesis is equals to 225. Okay. So what are the things we know? We know alpha, right? So you know the sample size, n is 10. Okay. Then what is this guy?
That's your X, right?
Little s. Very good. Is that s? Little s squared, right? Variance. So this is sample variance. That is 206. Okay. So now we are testing this hypothesis. If you draw a picture now, remember we are under chi-square distribution. So which kind of test now? This is a left tail test. We have color left side. Now this is going to be my alpha. That is how much? 0.05. That means which method are we going to use here? So let's see about my nodes. So we use a normal traditional method, right? Therefore, I'm going to find the critical value. So this is the critical value. Now remember, my critical value is what? Chi-square. So this is chi-square distribution. Now, okay. So left area. You know the degrees of freedom, which is n minus 1, but n is now 10, therefore this is 9. Okay, they say that critical value is 3.325. How do you find that in critical value? Any suggestion?
Well, you could just use the chart.
Exactly. But you know the area now, right? So you have to look for the chi-square value. Therefore, this is my chi-square distribution, right? You know now area, right? So you know the area, but I'm looking for the chi-square value. What is that? You know the area. Remember I told you last time, when you use the chi-square, chi-square table will be given for the right area, but I need to find now what? The left critical point. So you have to understand clearly. So we are going to look at this point. Therefore, you have to look for the area, anything, right side of this point because of chi-square distribution table we are using. Therefore, we need to know the right side area of the critical value. So this is a 1 minus of 0.05. That is 0.95. So you have to look for a 0.95 area with the degrees of freedom 9. So 0.95 with degrees of freedom 0.95 is here. 1, 2, 3, fourth column with degrees of freedom 9. You see there 3.325. Okay. So this is the way to find the critical value. So that is 3.325. Okay. So, but the test statistics says that test statistics chi-square is at minus 1 s squared over sigma squared, and is now 10, 10 minus 1 times. The sample variance is 206, and over the population variance is 225. Plugging all the values will give you 8.24. Where is that? Oh, it is far away from critical value, right? So 8.2524 is somewhere here. So it is obvious that my test statistic is now falling in a non-critical region. Therefore, we do not reject H naught. Okay, so do not reject H naught. That's not enough evidence to support your claim. Okay, so the next one again, we are using a data set. So if you want the data set, you will find S, right? So that is S6 in your calculator, plugging all the values and find S, or you can do manually by using the formula, whatever you like. We use that, okay? So if you do correctly, use the calculator, enter everything and find out little s6. So they say that it is 11.2. Why don't you check that? So I'm leaving this part, okay? So you could check later. Please check this whether you are getting this 11.2 after plugging these all the values into your calculator and little s. Okay, so the question is whether the hospital administrator believes that the standard deviation of the number of people using the outpatient surgery per day is greater than 8. Okay, that is greater than 8. It's going to be right tail test. And the random sample is now 15. And the data alpha is zero point 0.1. And okay, remaining all same. So alpha is now a zero point 0.1. So that is right tail test. Okay. So zero point 0.1. So if you want, you could use the p-value test or whatever you like. So now again we are finding the critical value. The critical value says that it is 25.064. Sorry, 21.064. So this is my critical value for this problem. Again, I am asking you to check. So my test statistic is 27.44. So that is going to fall inside the critical region. Therefore, we reject our hypothesis. Testing H naught rejected, right? Okay, since we reject H naught, our claim is correct. So therefore, that's enough evidence to support our claim, right? Okay. Oh, this problem is kind of a different problem. Remember, we don't have an option in your calculator to use chi-square test, okay? So there's no chi-square test in your calculator. So it is, that is said, right? So we can't use the calculator, right? But that's why we use that always. But then how do you find the p-value? P-value for this critical value, okay? Critical value and n is given. So they are asking us to find the p-value, right? Okay, so if you look at the picture, they are telling it is a right tail test. Remember, I'm in chi-square. So this is right tail. This is my chi-square distribution, right? So the degrees of freedom, therefore, n minus 1, n is 8, so which is 7. Okay, so now this is my critical value. Remember, sorry, sorry. Remember when you do the p-value, that is not critical, that is test value, right? We need test value. The test value is given. That is this. So you know the test value, 19.274, this value. So you are asked to find the p-value. P-value is nothing but the area of right side of the test value, right? Now we need to find this area. Okay. Oh, so you have to understand clearly now. Now you had to go backwards, right? You don't know area, but you know the test value. You know the chi-square value. So you have to go backwards now, right? So you know the chi-square value. So I'm looking inside the table now. You are going to figure out which value I need to figure out. My chi-square value already know 19.724. So I'm looking for 19.724 inside the table with the degrees of freedom 7, right? So remember, you know only test value. You don't know the area. So I'm looking for the area, okay? Alpha, in other words. So 19.27 with degrees of freedom 7. Where is that? Degrees of freedom 7 is here. I'm looking for 19.274. Do you see 19.274 here in my you know the row degrees of freedom with 7? No, I don't see 19.724, right? You don't see that value. But anyway, you know the 19.724 is somewhere between 18.475 and 20.278. Okay? Even though I don't know exact value, I could say that hey, the area 19.724 is between 18.475 and 20.278, right? Therefore, that is why if you look at here, they explain everything in clear way to the degrees. This is my chart, okay? So this is the chart I'm looking for. So the degrees of freedom 7, and we are looking for 19.724. That is not there, but in between these two, right? That means the corresponding p-value or area is between zero point 0.01 and 0.005. Therefore, my p-value is now between these two values, right? Remember, p-value is nothing but the area. The area is here at the top. This is basically the area, right? Which area? Right side area. My right side area is nothing but the p-value. So my p-value is now between these two values, right? That is 0.005 and 0.01, right? So now this is my answer. I don't know exact p-value. Instead, I have interval. I'm 100% sure that my p-value for this problem is now falling in this interval 0.0005 to zero point 0.01. Okay, so we can't find the exact value right now. So that's what this explains. Okay, so this problem also kind of similar, right? So you need to find the p-value. You know the test chi-square value is given and the degrees of freedom again 12. So you are looking for the 12, right? So you are looking for 12 and the, oh, what kind of test this is now? This is left tail test now. So if you draw a picture for this problem, now I have left tail, right? So my test value now is given 3.2, sorry, 3.823. Therefore, this is my p-value, the area, left side area. Okay. Oh, now you see, if you look at your table, table will give you right side area, right? First find the right area, then subtract from 1 this area to get left area. I need left area. Okay, so that means I'm looking for now this value, my test value, but what is the degrees of freedom for this problem? N is 13, therefore degrees of freedom is 12. So I am looking for the value chi-square inside the table with 12, okay? So 12 and 3.82. So 12 is here, degrees of freedom is 12, 3.8. 3.8 is somewhere near 3.571 and 4.404, right? That means between 0.99 and 0.975, okay? That is why they explain here, right? 0.99 and 0.975, okay? That means you need to get the left area, so you have to subtract, these two from 1 to get two different values. That is why they are doing here, subtracting 0.99 from 1 to get one answer, and again subtracting this guy from 1 to get the another answer. So that means my p-value is now going to be between these two values. Okay, so that is why you have that. So this is kind of finding the range of the p-value, right? I don't know how they got this in calculator. I'm trying to figure out, but at this point I don't know how they got this. And okay, so this is the way to use the chat. Okay, you have any question? Okay then. This is the last section we have in chapter 8. So the additional topics regarding to the hypothesis testing. So now here we are going to have the combined results with the confidence interval and the hypothesis testing. These two are two different things we learned, in chapter 7 about the confidence interval. Now we are in a hypothesis testing. Now we are going to combine my, the summary or my final answer by using my confidence interval answer as well, combining this with my hypothesis testing. Okay, so let's look at the first problem. Sugar is packed in 5 pounds bag, and inspector suspects that the bag may not contain 5 pounds, right? So he's suspecting whether 5 pounds is really there or not. So this is going to be the inspect is alternate not equal sign. So this is going to be equal sign with the population mean, average mean, population mean. So in average he's checking this. Okay, so he's picking random sample of 50, right, with the mean 4.6, therefore x bar is 4.6, and the standard deviation is zero point 0.7. Remember that standard deviation for the samples, therefore little s is 0.7, right? Remember? We don't know population, standard deviation. Instead, we have sample standard deviation. If we do not know the population, we are going to use the t statistic, right, for the mean problem. So we use t statistic for the mean problem. So the remaining all like earlier we did. Okay. So you know the alpha, and if you do this problem, so you are getting two tail test now. Therefore, you have two areas. The critical values are these two, right? The picture says that exactly. These two are my critical values now. If you find the test value, my test value is t x bar minus mu over little s over square root n. You know all the numbers. Plugging here, you got negative 4.04. So this is our test value. Of course, test value is now going to be inside the critical region. Therefore, we reject our null hypothesis. So there's enough evidence to support our claim. So up to this point, we follow our testing hypothesis procedure. Now we combine this answer with my the confidence interval. Now this part right over here is separate problem, right? So this is kind of separate thing. You have to use the confidence interval formula we learned in chapter 7, right? The confidence interval for mu when sigma is unknown case, right? Under chapter 7. So we had this formula, remember? The confidence interval for mu. So you know all the values, T alpha over 2 here, my critical value exactly, that is 2.014. So you can go and check your chapter 7 notes if you have a doubt. So we find here the confidence interval. Therefore, the confidence interval for our, the population mean is 4.4 to 4.8. But our hypothesis result says what? The hypothesis result says there's enough evidence to support your claim. That means you accept your claim, right? So where's my claim? My claim says that what? Your claim says that, hey, look at your claim. Your population mean is for sure, now not is that is not 5, right? Therefore, the population mean, right, should not be 5, but you find the confidence interval for mu. That means what? That means the possible answers for population mean is now 4.4 to 4.8. Yes, that is correct because I don't see number 5 in this interval, right? If you have number 5 in your, the confidence interval mu, that means you have to exclude that 5 in your interval, right? Because your interval should agree with your hypothesis results. Okay, right? So now we are good because I don't see number 5 inside this interval. Therefore, for sure, I know my mu is not going to be 5. My possible mu answer is now 4.4 to 4.8. So this is correct. So notice that 95 confidence interval for mu does not contain the hypothesis value mu 5. Hence, agreement is correct. Agreement is there between my hypothesis and the confidence interval. Okay. So you have to make sure that you are finalizing your confidence interval with the decision of your hypothesis. That makes sense? Okay. So now look at this problem. The researcher claims that the adult hogs fed a special diet will have an average weight of 200. Okay. So this is mu, no? The random sample of 10 hogs has an average weight is this is my x bar now. So little n is a 10. This is going to be my mu, right? 200. So we are suspecting whether this is correct. And alpha is 0.05. So you know all the numbers. So and also find the 95 confidence interval. Find these two now separately, and let's see what's happening. So again, I have a two-tailed test, and I do the things like earlier we did. Again, you know the sample standard deviation. Do you know the sample standard deviation? Yes, 3.3. So little s is 3.3. So plugging these values into your formula, the critical value is now 2.262 and 2.262 negative because of 210. And again, the critical values in these two and the rejection areas now two regions. and the test statistic is now negative 1.72. So negative 1.72 is now falling here. Oh, that means what? That means we do not reject our null hypothesis, right? Oh, we do not reject. So what does mean by that? We do not reject. This may be correct. Your mu is now 200, right? That means what? When you find your confidence interval, the mu 200 should be there inside. Let's see. So if you find the confidence interval now, do the thing, this one separately. Use the formula for the confidence interval, right? So you're plugging all the values. Now you see, this is the interval I got for mu. Yes, 200 is inside the mu now, right? Mu interval. Therefore, yes, my confidence interval answer now agrees with the hypothesis research, right? Therefore, yes, makes sense. Okay.
Will it always agree?
It should agree. If it is not, you have to exclude those points in your confidence interval. Your confidence interval, the most of the case it should agree, but there are some cases it will not. So in that case, you have to exclude. Okay, if it is not in your hypothesis testing. That's what I explained in the previous problem, like this problem, right? In this problem, right? We reject my null hypothesis. Therefore, you say that your mu for sure is not going to be 5. In case if you get your the confidence interval mu, say you are getting some answer, I don't know, say 4.4 to say 5.1. No, that's a trouble, right? Why? Your interval says that 5 is included here, but you are telling in hypothesis 5 mu is not equals to 5. Therefore, what you have to say, your confidence interval, this is correct, but you have to, exclude.
So if it's outside your critical value, it's always going to be outside your confidence level too. I mean, those two tests should agree with each other.
Exactly. That's what I'm trying to
Okay.
say. So it should agree with each other. Yeah, you're correct. Makes sense, right? Okay. So now this is the last note I'm giving you. So we are not going to look at in detail this, but anyway, I'm just including this. The power of the hypothesis testing, right? If somebody asks you, hey, what is the power of your test? The power of the hypothesis test is given by 1 minus beta. Okay, remember the beta? We had this, right? Beta is my type 2, the probability of type 2 error, right? So beta is the probability of type 2 error. Remember that type 2 error means what? Type 2 error means you are making mistake, error, when H naught is not true, right? If H naught is not true, you have to reject, right? But accidentally, you are accepting. No, you are not rejecting. So this is kind of error you are making. This is we already discussed this in now very beginning, right? So that is going to be my beta. So first find the beta, find the probability of this guy. Once you know beta, subtract from 1 to get the power. So the power of the test is nothing but 1 minus beta. Okay? So this is just for, yeah, I just included this. So this is all about the testing hypothesis. So summarize. So let me summarize these things. First, we had the testing for what? We had the testing for mu, right? Population mean. So we had two cases, right? One is sigma is null, then we use z-test. Then if sigma is unknown, we use t-test, right? Test value is now t distribution. After that we had, so this was our first one. Then we had what? The hypothesis testing for what? For the proportion, right? The population proportion. So again, we used here z-test, right? Z-test that. Then today we saw about testing variance, population variance, right? So what kind of test we used here? We used the chi-square test. These are the things now we learned in this chapter 8. Okay? Okay.